Electronics. Today's video is some tips and tricks to crack the competitive examinations of electronics. That can be any competitive examination. So some small tricks and some tips I have included in this video. So the basic tip is that whenever you are preparing for any examination, these things I'm always saying in all my videos throughout, whenever you are preparing for any competitive examination, the first thing you actually need to do is do practice maximum previous year question. Consider that you are preparing for GATE, then try to solve the previous year questions of GATE electronics. Channel is mainly focusing on electronics, that's why I'm saying electronics. Whichever subject you are concentrating on, you should practice the previous year questions of those subjects. Rather than just studying all these materials vaguely, you should know that what all things are being asked in the previous years. So, for getting a clear picture of the previous year's examinations and the previous year's mark allocation for various subjects and all, you should try to practice the maximum previous year questions. That is, maximum number of questions you able to practice means that much it is good for you. Rather than just diving to the sea vaguely, you should get a clear idea of the route you should go. So for making that clarification, practice maximum previous year question. That is the first and the biggest tip. Next is make maximum formula revision notes. You know which are your core subject. From whichever branch you are belonging to, you should be knowing that these are my core subject and these subjects I should give more importance to. So first try to make a formula revision notes of those subjects, because you know that maximum questions can come from this area, and if you make formula revision notes means it is very useful for your end time preparation. So that is the second tip, that is make maximum formula revision notes of, no need to make formula revision notes for all your subject, that is nearly impossible, but try to make formula revision notes of all your core subjects. So in this channel, I'm focusing on the formula revision videos, especially for all the core subjects we are doing videos. So that is the next tip. Then third tip is basically for electronic subject. It is also applicable for all other branches also. Study the symbols and the basic working of all the components. See, consider that there are various electronic devices. There are diodes, there are Zener diodes. You should know the basic symbols, because if you study the symbols, only then you should be able to identify from the circuit that this component is being used. And if you know only the basic working, then you should try, then only you should be able to figure out how the circuit is actually going, what is the voltage, what is the current. So all those things, if you need to know, or if you could clearly answer the question, you should know the basic electronic components symbols, and also you should know the basic working, that is how the resistor is working, what is a series connection, what is a parallel connection. All these basic things you should be knowing. And if you also make a note of, there is a small note of these symbols and its basic working, that is also very good for you. Okay, so these are some tips. These are the three important tips you should follow if you are going to attend any competitive examination of electronics. First one is maximum previous year question. If you are practicing for ECE, do maximum ECE questions, that is in the previous year questions. Then make maximum formula revision notes of your core subjects. Then study the basic symbols of electronic components and also its working, so that whenever some circuit is given to you, you should be able to figure out that how is actually this circuit going to work. Okay, so these are the first three tips. Next, I'm going to give you some of the tricks which would be useful for you for solving some resistor problems, especially series and parallel connection, and also some of the important units. There is some problems you can encounter in the competitive examination with these units, some logarithm things, and also these things we are going to see nextly. Okay, next I'm going to give you an important tip for answering these confusing resistor problems. You know that whenever you are going for any competitive examinations of electronics, there will be more than 2 or 3 questions from this resistor equivalent. It can be either find the equivalent resistance, or it can be either find the current through this resistance. For that, you have to actually solve the equivalent of the circuit. There can be questions like that. Okay, so how to actually figure out whether the connection of resistors, any two resistors, in series or parallel. So the trick is that whenever you want to find the resistors, whether it is in series or parallel connection, you should always see the terminals. That is, if both the terminals are connected together, that is a parallel connection. And only if there is one terminal in common That is, if only one terminal of the two resistors are common or connected together, then it is a series connection. See here, the first is a series connection. R1 and R2 are the two resistors. Only one terminal, that is this terminal of R2 and this terminal of R1 are only connected together. The next one or the next terminal, this terminal of R2 and this terminal of R1 is not connected together. It can be connected to any other resistors or voltage or source or anything or any part of the network. So this connection is called a series connection. Whereas if you see the next connection, here the two terminals, both the terminals of R1 and R2 are connected together. See this terminal, they are connected together of R1 and R2, and these two terminals are also connected together. So this is actually a parallel connection. Okay, so whenever you are going to solve these resistor equivalent type of questions, you should always see for the terminals. That is a trick. Now, another important thing is that you can either do the current flowing or the voltage. If you see for the voltage across the resistors, or if you see the current flowing, how it is getting splitted, then you can also identify whether it is connected in series connection or parallel connection. I'll give you the trick. For a series connection, you know that if a current is passing through R1 like this, or if a current is coming in this direction, it will entirely pass through R2, right? There is no splitting, there is no branching of the current. I hope it is clear. For a little moment, I'll remove this R2. Okay, now you can clearly see there is R1 here, there is R2 here. If a current I is coming in this direction, it will entirely pass through R1, same as that of R2. So the current is same, right? So that is another trick to solve these problems. Current is same for a series connection. Whereas for a parallel connection, if a current is coming like this, it will get splitted across. This is R1 and this is R2. It is actually getting splitted. So the current is not same, and hence it is not series connection. But if you see the potential difference between these two terminals is same. Consider if the potential in this end is V1, in this end is V2. So the potential difference seen from or seen on R1 and R2 is the difference between V1 and V2, right? So the potential or the voltage is same for a parallel connection and the current is same for a series connection. This is a trick to remember, or this is a trick to solve these resistance equivalent type of problems. You have to see whichever resistance you want to solve. See its terminals and current and voltage. Then you will be able to figure out. Okay, and also everybody will be knowing this. Equivalent value for a series connection is R1 plus R2. And the equivalent for a parallel connection is 1 by Req is equal to 1 by R1 plus 1 by R2. It will go up to n numbers. Okay, n number of resistors can be connected in parallel or in series. It will go in a infinite method if the connection is infinite. Okay, now we are going to solve one problem of resistance connection. This is a circuit here. Okay, so you can see here there are 1, 2, 3, 4, 5 resistors. And if you want to solve this, you can start from this end. See, there are two resistors, and what is the connection? See for the terminals. Here both terminals connected together. Here also both terminals connected together. So it is a parallel connection. And I'm going to write the equivalent. Both the resistors are having 1 ohm. So the equivalent is 1 by 2, right? So this is a 1 by 2 ohms. I'm going to write 1 by 2 ohm here. That is the equivalent value. The question is to find the equivalent resistance between the terminals A and B. So here, if you see, this resistance is having 1 by 2, this resistance is having 1 ohm. Now see for its connection, this resistance and this one. What is the connection? Here, one terminal is common, that is connected together of the two resistors. But the next terminal of this resistance and this resistance are not actually together. They are separated, connected with the central 1 ohm. So this is a, what connection it is? It is a series connection. Because only one terminal is connected together or common. Okay. So it is a series connection. So 1 by 2 plus 1 is 3 by 2 ohms is the equivalent. Okay. So this is some trick where you can fastly solve the resistance problem. So it is a 3 by 2 ohms. Now this is a 3 resistance now left out, and here you need to find the equivalent between A and B, right? Clearly you can see for these 3 resistors, their terminals, both the terminals of the three resistors are connected together. See here, this forms a bundle of three resistors. Here also, all the three terminals are connected together. So what is the equivalent? It will be the, it is a parallel connection. So these three resistors are connected in parallel. So they are in parallel connection since these three terminals here also and here also connected in parallel. And if you solve it, you need to apply the parallel theorem. For parallel equation, the equivalent resistance coming is 3 by 8 ohms will be the equivalent. Okay, just apply the parallel rule here. So you can identify it clearly and the equivalent is 3 by 8 ohms. So this is how you should figure out whether the resistance are connected in series or in parallel. Okay. Next important tip is that you should be familiar with these units. There are a lot of other units, but at least these units you should be familiar with. That is 10 raised to 3 is represented as kilo or capital K. 10 raised to 6 is mega or M. Megahertz. Likewise, mega ohms. 10 raised to 9 is giga. 10 raised to 12 is tera. Why I am saying is that sometimes the value of resistance or anything, voltage or anything will be given in this unit, milliampere or a millivolt or mega ohms. Then you should be knowing that mega means 10 raised to 6. Only then you can proceed to the numerical, right? So you should be thorough with these units. Okay, 10 raised to 3 is kilo, represented as K. This also you should be knowing because it won't be given as kilo ohms, it will be K ohms. Okay. Then 10 raised to 6 is mega, 10 raised to 9 is giga, 10 raised to 12 is tera, T, giga is G, mega is M, kilo is K. Also, you should be knowing these units. Negative, 10 raised to minus 3 is milli, represented as small m. 10 raised to minus 6 is micro, it is represented by mu. 10 raised to minus 9 is nanoseconds. Then 10 raised to minus 9 you should put as value. Nano is n. 10 raised to minus 12 is pico, it is P. Now, also, there can be some problems in which after finding the numerical, you should be getting some value. But the answer will be given either in microseconds or in micro volt or likewise. Then you should be knowing how to decimal adjust and find the exact value. Because sometimes you should miss out some zeros and you should get confused and you may not get the correct option. So, I am giving you some example. There is a variety of examples. Like consider that the value you are getting is 0.6 into 10 raised to minus 4. How can you write this in micro? 0.6 into 10 raised to minus 4 you can write as 60 micro anything. Consider it is microseconds. Okay, so 60 microseconds. 0.6 into 10 raised to minus 4 is, that is you are putting 2 zeros. That is here 0.6 into 10 raised to minus 4. Right, 0.6 into 10 raised to 2 into 10 raised to minus 2. Now this get cancelled, right? This 10 raised to 2 and 10 raised to minus 2 gets cancelled. So how will you write this 0.6 into 10 raised to 2? It is 60. And how is 10 raised to minus 4 into 10 raised to minus 2 is 10 raised to minus 6. So that's why it is 60 into 10 raised to minus 6, or you can write it as 60 microseconds. I'm just putting seconds. It can be any value of in micros. Okay. So that's why this type of adjustments you should do to get the exact answer. Because sometimes the answer will be given in the options in micro or milli or in nano can be. So you should be able to figure out the exact answer. So this is some things you should know or you should practice. 0.6 into 10 raised to minus 4 is 60 micro units. Okay. Then other example I'm putting here is 200 you can write as 0.2 kilo. Okay. Because sometimes these values will be given in kilo. So 200 you can put as 0.2 kilos. Okay. So these type of units and its conversion by decimal adjusting is very important if you want to get the exact option. Okay, so if you are practicing for these competitive examinations, you should be knowing at least this much of units thoroughly. Okay, that is, these are actually power values. These power values you should be knowing thoroughly to actually get the correct answer in these competitive examinations. Another important thing is the dB values. See, mostly we represent the power and the gain of antennas or any transmission system in dB values. So after doing all the numericals, you will be getting some value, but you got confused that the options are entirely different from your obtained answer. Then you have to clearly check that whether the value is given in dB or not. Most time, that is 90% of the time, the values will be given in dB. So you should be knowing how to take the dB value of a particular ratio. By ratio, I mean that there is power in by power out. So this is a ratio, right? Or it is a gain. Then you have to take the dB value of that particular answer. That's what I'm saying. So the answer, in order to find a value in dB, that is the answer in dB is equal to 10 log 10. So 10 into log to the base of 10 of that particular value you have in your hand. So in order to get the dB value, you should do this. And if in some question the dB value is given to you, and for example, in order to get the received power of a antenna, the value of the gains and everything is given in dB. But while doing the calculation, you need the exact ratio value. So you have to do the reverse. So for that, you should do this. For getting the ratio of whether power or gain, take the 10 raised to answer in dB by 10. Okay, so this is the thing you should do. 10 raised to the answer you have in your hand, that is the dB value, by 10. 10 raised to 10 to the power of this value. So this is the very important thing, because many people doesn't know how to take the dB value and the reverse. Because even if you know the answer, if you don't know how to do the dB conversion, the options will be in dB, so you should not be able to answer. So please make a note of this, how to take a dB value and how to do its reverse. The next method is an approximation method, which is very useful if you are going for the examinations of ISRO and other public sectors where you are not allowed to use calculators. Okay, so please carefully listen how to do. I'm just giving you an example. There is a lot of other type of problems also. So while going for classes of, or while seeing videos on aptitude techniques, you will be getting a lot of other tricks also. But I'm just giving you a small gist that you can also do sums without actually using calculator. See, the question is, I'm not writing any question or anything. The question is actually to find the efficiency. This question we have discussed in one of the previous videos. Okay, so the efficiency we need to find in the question. PAC by PDC into 100 is the formula. We know this much is the sum we need to calculate. The answer is 48%, 50%, 52, and none of this. Okay, so this sum, how can we solve without calculator? In the numerator, you can see there is a 12.5. In the denominator, you can see there is a 2.5. So you can write this as 125 and you can write this as 25. Right. Now, here there is a 125, there is a 15. If you cancel it by 5, you will get as 25 here and you will get a 3 here. Right. You can also cancel with this to 125 and 25 also. I'm doing this way. So 125 cancel with 5, you will get 25. 15 cancel with 5, you will get 3. Again, you can cancel this 25 and 25. I'm going to remove this. And this much is the left out. Okay, there is a 100. I'm not using any calculator on anything. Even though there is a pi value or decimal value is there, you can also do without calculator. There is a 100 here. There is 3, 2 by pi. So this pi, you know that the value is 3.14, right? So approximately it is equal to 3. So if you want, you can cancel out 3 and 3.14. But I'll keep it that as it is for the moment, and try to cancel this 100 by 2. So what will you get here? It is a 50, right? So this much is left out here. 3 into 1 by, there is 3 into 1 by 3.14 and 50 in the numerator. Okay, so this 3 and 3.14, if you want to cancel, you can cancel. But you know that something will be left out here. That is 3.14 is little bit greater than that of 3. So the value in this denominator is actually 1 by some decimal number, right? It is not 3 point some decimal number. I'll write it that like that. So 1 by some decimal number. So if you take the reciprocal, you will have to multiply that point value or that decimal value with this 50. Now we'll put as it is and we'll look for the option. The options are 48. It is not clearly 48 because we are multiplying 50 with that decimal number. Next one is 50. No, it is not clearly 50 because 50 plus something is there. Then C is 52. So 52 has to be our answer because we are actually multiplying 50 with that decimal number. So it is something more than 50. So that's why the answer is 52. So while using calculator also, you will get the answer as 52.3 or approximately 52%. So this type of techniques you can use, that is approximation techniques, you can use to do these problems or numericals more easily without even using calculator. Next we will see the three basic logarithms which we generally use in the numericals or in general problems. Okay. So the logarithms are natural logarithm is there, log to the base 2 is there, log to the base 10 is there. These two things we generally use, that is log to the base 2 and log to the base 10. Then what is natural logarithm? Log to the base e is a number 2.17. That is a approximate value of e. Anyway, when you want to find the value of x, that is ln to the base e, that is if you want to find the natural logarithm of x, you have to represent x as e raised to y. Okay, so whenever you want to represent or find the value of ln of x, then you have to represent ln e of e raised to y. That is, you will write x is equal to e raised to y, then y will be your answer. Okay, so that is a simple expression or notation of taking of natural logarithms. Next, how to find the log to the base of 2. I'm just writing an example here. Log to the base 2 of 32. You have to write 32 as powers of 2. These logarithms we generally take to the base of whatever number, we write the number as powers of that base. So here base is 2. So log 2 raised to 5, because 35 is equal to 2 raised to 5. So the answer is 5. Okay, that is, you can write 5 into log 2 of 2. Log 2 of 2 is equal to 1. So the answer is 5. So that's why we'll be doing that log to the base of 2. Similarly, for finding log to the base of 10, for example, I have taken 10 raised to 3. So I'm going to write log 10 power 3. I'll take this 3 outside. So 3 into log 10 of 10. This is 1. So the answer is 3. So these are some of the techniques which you have to apply, or this is how we take the logarithms, natural logarithm, log to the base of 2 and log to the base of 10. This is also very important if you want to do these numericals, because in a lot of problems we need to take the logarithms for calculating CMRR or in order to calculate the value in dB. All these things we need logarithms. Okay, so that's why I've included this also. These are some tricks and tips which I have included in this video, which is especially for branches ECE, EEE and EI, because I'm mainly concentrating on electronic subjects. So if you are preparing for any competitive examinations of electronics, these tips you can actually use in your examinations. Next, we'll be doing a video on time management also. If you're interested in watching that video, please do mention in the comment section. I really hope that this video was useful for your preparation. If yes, please do give it a thumbs up and also share this video with maximum of friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.